All right, ladies and gentlemen, welcome back to 5 Minutes of Math. This is Mr. Lunsford, and thank you so much for joining us. All right, so this is number 17. This is homework for the evening of Wednesday, December 20th. And this is a problem about snowboarding. And in this problem, she has saved $550 for lessons and a junior season pass. Okay, so we see here that 550 equals the amounts of the junior season pass plus the lessons. So we break that down, that's $315 plus the cost per lesson times the number of lessons, okay? And all of that has to add up to what she's already saved. So it's 550 equals 315 plus 45x, okay? And x is just our number of lessons. First thing we're gonna do is 550 minus 315 equals 315 minus 315 plus 45x. And right here, we're just looking at the semi-private lessons. 235 equals 45x. Divide both sides by 45. 5.2 lessons is what we come out with. Now, if we go over here to the private lessons, 550 equals 315 plus 60x. Each one of those lessons is $60, and the semi-private ones were $45 a piece. So 550 minus 315 equals 315 minus 315 plus 60x. Now we have 235 equals 60x. Divide by 60, and now we end up with 3.91 lessons. All right, but right here, we got to use some common sense. So let's start thinking about this thing. We have to assume that both instructors only teach full lessons. So they're not going to teach for free, and they're not going to teach a piece of a lesson because that's going to leave somebody stranded on a hill somewhere. So we're not going to use our decimals or our fractions. So with the semi-private lessons, we came out with 5.2. There's no such thing as 0.2 lessons. All right, so instead of 5.2, we're just going to use the number 5. Same thing for the private lessons. The instructor is responsible, and we ended up with 3.91 for that one. We're going to stick with our original assumption that the instructors only teach full lessons. Now, 3.91 rounds up to 4, but like most teachers, we're not doing anything for free. Now, this rounds down in this case. Mathematically, 3.91 rounds up to 4, but the instructor's not going to teach any free lessons. So it's 3.0 is the number of full private lessons that Elsie can afford. So Elsie can afford 5 semi-private lessons, but only 3 private lessons. So 5 minus 3 is 2. All right. So she can afford 2 more semi-private lessons than she can private lessons. Now, one more thing I wanted to add. You guys don't have to write all of the words that I'm writing, but I do want to see those numbers and I want to see those steps. And I never told people exactly how much they should write to get full credit. And if you're doing that, that's fantastic. I'm giving you full credit and extra credit and everything I can give you. But I need to see at a minimum the math. If you can track your answer back to the problem with the math and the numbers and the operations, I'm happy. All right, so moving on to the next one. All right, ladies and gentlemen, this is number 18. And in number 18, we are asked to look at consecutive integers that add up to another number. Now, an integer is not what you would find if you just Google the term. It says a whole number. Mathematically, it's a number with no fractional parts. They include whole numbers, but they also include negative numbers that don't have fractions. Now, our answers for this problem are going to include whole numbers. I'm going to leave it there, but just know that integers include negative numbers that don't have fractions. So the sum of 3 consecutive integers is 36. So let's break this down. What does that actually mean? Okay, so if one integer is equal to 11, then what is the integer? Well, obviously, this one, if we have a number a equal to 11, then a is 11. All right, now I know that sounds ridiculous, but I'm going somewhere with this. If the sum of 2 integers is 11, then what are the integers? Well, now we have a plus b equals to 11. Now, there's a lot of possibilities here. A could be 10, b could be 1. 10 plus 1 is 11. Y'all learned that back in first grade. The numbers, though, are not consecutive. Consecutive numbers, again, have to come right behind the other one. What's another combination we could use for 11? A could be 9 and b could be 2. They do add up to 11, but they are not consecutive. All right, so let's look at another combination. We could possibly look at 8 and 3. 8 and 3 do add up to 11, but they don't come right next to each other on a number line. The only two integers that are consecutive and add up to 11 are 5 and 6. So if A is 5 and B is 6, and A plus B is 11, 5 plus 6 does equal 11. Now we look at the relationship between 5 and 6. All right. So how else could we explain 6? Well, 6 is just 5 plus 1. See the triangle? Now, if we go on to look at that whole problem, 5 plus 5 plus 1 equals 11. So let's just replace 5 with the letter X. X represents the same number here, and in this case, we're going to go X plus 1 equals 11. Do we still get 11 if we solve this algebraically? And you'll notice I'm going through the steps here. X plus 1 equals 11. We combine our terms. 2x plus 1 equals 11. And then 2x equals 10. And again, I just subtracted 1 from both sides. I didn't show that step, but I did do it. And then we have 2 times x equals 10. Just divide both sides by 2. X equals 5, and then x plus 1 equals 6. So those are our two consecutive integers that add up to 11. Now let's go back to our problem. Now again, we're going to end up with whole numbers, but integers include all numbers that do not have a fractional part. So if the sum of 3 consecutive integers is 36, then what are the integers? So let's pick 1, 2, and 3. What's the relationship between 1, 2, and 3? Well, 1 is just the number 1, 2 is 1 plus 1, 3 is 1 plus 2. Now, if we replace 1 with x, then that could stand for any number. We have x, x plus 1, and x plus 2. So does that work? Let's say we plug in, oh, I don't know, let's just pick a number here. 6, 7, and 8. So 6 is just 6, 7 is 6 plus 1, and 8 is 6 plus 2. X plus 1, and x plus 2. And 6, 7, 8 are consecutive numbers. Let's plug in 100. All right, so 100 is just 100. 101 is 100 plus 1. 102 is 100 plus 2. So x plus 1, and x plus 2 are 3 consecutive integers. Now, let's form up our equation on this side. The sum of 3 consecutive integers. So we're going to take x plus 1, and x plus 2 and add them, all right? We're going to combine all 3 of those quantities. So x plus 1 plus x plus 2 equals 36. So let's look at how that works in an equation. All right, so there's our equation again. X plus 1 plus x plus 2 equals 36. So let's combine our like terms. The variables are in yellow. So that's x, 2x, and 3x. X plus x. And then we have 1 and 2. All right, they're constants. So x plus x is 3x. 1 plus 2 is 3. 3x plus 3 equals 36. All right, so we've combined our terms. Now we're going to subtract 3 from both sides. And because we've gone over the properties, I can call it what it is. This is additive inverse. And we use our opposites to move our constants around. Now, 3x equals 33. Divide both sides by 3. We have x equals 11, but there's more to it than that. All right, you're going to notice that x equals 11, but x plus 1 is 12, and 11 plus 2 is 13. So it's 11, 12, and 13. Now, does that add up to 33? Let's see if this algebra stuff works out. 11 plus 12 is 23. 23 plus 13 is 33. Yeah. So we found our 3 consecutive integers that add up to 33. Not magic, just math. Thank you so much for listening, and I hope you guys have a great break. All right. Talk to you soon.